Okay, so this is the solution to test number 2. So the first problem was this implicit differentiation problem. So we had two products, so we had to use the product rule twice. So this was a product of x times y. So we could take 2, the constant, and then the product rule says you take the first term times the derivative of the second plus the second term times the derivative of the first. So normally you take derivative of y would be just 1, but because it's implicit, you put a y prime. The derivative of x is 1, so it just comes down. Now the same thing applies here with this next one. So the derivative of the cosine is negative the sine, so you get negative 10 sine of y. So if we had the cosine of x, the derivative would be negative the sine of y. But because we're taking the derivative with respect to x and the variable is y, we have to add on this y prime. Then here we have 4 times the derivative of this product, so it's the first term times the derivative of the second. Again, you add the y prime when you take the derivative of y squared. And then you have the second term times the derivative of the first. And then on the right-hand side, it's just normal differentiation because it's x, so you get 60x squared. So let's multiply all these out. So you get 2xy prime plus 2y minus 10 sine of y times y prime plus, okay, here we have 4 times 2 is 8. Then we have x, then we have y, then we have y prime. So I've just put them in the order of constant x, y, and then the derivative of y. And then we have plus 4 times y squared, so we get 4y squared is equal to 60x squared. So we put all the stuff that involves y prime on the left-hand side. So there's going to be three items there. On the right-hand side, we've got these two terms, which they'll become negative when we move them from the left-hand side to the right-hand side. This second one will become positive. And then we've got plus 60x cubed. Then you factor out the y prime. So you've got y prime times 2x minus 10 sine of y plus 8xy. And on the right-hand side, I'm going to switch the order. I'm going to put 60x squared first because that's positive. Then I'll put plus 10 sine y. And I just realized I did something wrong here. What did I do wrong? Yeah, I made a mistake. So what did I do? Yeah, it's this thing I need to move to the other side. I don't know why I did that. So let's fix that. So you've got 4y squared, so that becomes negative 4y squared. Okay, so let's do this again. That's the main gist of this thing, is keeping everything straight. So this comes down, that comes down, this goes to the other side, this goes to the other side, that stays on the right-hand side. Okay. Just need to fix a sound problem here right now. Okay, so back to this. So I'm going to put the positive one first. Doesn't really matter which one comes next. So these are all the terms that don't involve y prime. And then to solve for y prime, we're going to have 60x squared minus 2y minus 4y squared divided by 2x minus 10 sine y plus 8xy. Let me double check I did that right. Yeah, okay, so that's the right answer. Okay, the next one is this related rates problem. So we've got things flying at right angles to each other. And we've got the distance. I'm going to call this y. I'm going to call this x. The distance between the two from here to here is s, whatever you want to call it. This is a right angle. So the Pythagorean theorem says that y squared plus x squared equals s squared. So that's my geometric relationship. Now before we get to do anything with that, let's just calculate x and y. So x, you take the velocity times the time. So for the x direction we had, that's the thing going east. So it's going 400 miles per hour times 2 hours, 2.5 hours. So that makes that distance be 1,000 miles. And y is going to be equal to the velocity times time again. In that case, we have 350 miles per hour times 3.5 hours. And you get, I guess it's 1225. Let me get my calculator out. So 350 times 3.5 is 1225. Okay, so those are the distances. And what we can do is we can use the Pythagorean theorem here to find s. So s squared is going to be equal to 1,000 squared plus 1225 squared. And to find s, we'll just take the square root of that. So 1,000 squared plus 1225 squared, take the square root of that, you get 1,581 miles. So we now know all three dimensions. Now, when we take the derivative of this Pythagorean theorem, we'll get 2y times dy dt, and the derivative of x squared is 2x dx dt, and the derivative of s squared is 2s ds dt. You see the 2's cancel out, so you just remove those. And the only thing that we don't know is that. That's what we're trying to solve for. We know y, we know x. dy dt is 350 miles per hour, dx dt is 400 miles per hour, ds dt, s is 1581. So what we'll have is ds dt is going to be y dy dt plus x dx dt, all divided by s. So y is 1,225 miles. dy dt is, let's see what it is. Y is 350 miles per hour. X is 1,000 miles. Dx dt is 400 miles per hour. We divide by 1,581 miles. You can see the miles cancel out, so we're just left with miles per hour, so ds dt. And it should be increasing, both because dx dt and dy dt are increasing, are positive. So 1225 times 350 plus 1,000 times 400, and then divide that whole thing by 1581. And what did I do wrong? Oh, I didn't divide. I took a power here. Divide 524. So the answer is 524 miles per hour. So you make sure you include the units in the answer. The first two problems are worth 30 points. Then we get to problem number 3. People did better on that one. So this number 3 is a chain rule problem. So if we have f of x equals x cubed plus 2x squared to the 6th power, we usually say that the thing in the parentheses is the u of x part. So you get x cubed plus 2x squared, f of u equals u to the 6th. So you take the derivative of each one of those. This one with respect to u, you get 6u to the 5th. Derivative here is 3x squared plus 4x. So the chain rule says that f prime of x equals f prime of u times u prime of x. So you get 6u to the 5th times 3x squared plus 4x. And then substitute in for u, so you get 6 times u, which is x cubed plus 2x squared, raise that to the 5th power, times 3x squared plus 4x. And I took a point off. Usually you want to have the highest order thing that's in parentheses last. So it's kind of level of complexity. So if you have something raised to a power, put that last. If you have it just by itself, you didn't need to multiply it out by 6. If you did it, that's fine. Somebody multiplied this by 6, but not that by 6. So just be careful when if you're making any simplifications. Okay, number 4. So this is an example of just using the product rule and for some reasonably simple derivatives. A lot of people in this class put in some assumed parentheses, which I didn't put in there. So if I don't put it in there, don't assume it. So some people did x squared times tangent of x minus 5x cubed. But that is not what it says. It just says what it is what it is. So I've got a product here, and then I've just got a simple term there. So the first two terms, the product, you take the first term times the derivative of the second plus the second term times the derivative of the first. So that's the result, the product. And then this one you just use the power rule. So you take 3 times 5 is 15. Reduce the exponent by 1. And then the final answer, we put the polynomial first, the trig function second. Here we'll put the constant first, the polynomial second, the trig function third, and then your final answer. So that's it. That one was worth 20 points. The previous was worth 20 points. Number 5. So this is a chain rule problem. A lot of people wanted to use the quotient rule, but you can still get the right answer. And I didn't take off if you got the right answer, but more likely than not, you made a mistake because it got too complicated. So you made it more complicated than you needed it to be. So the chain rule would say that I can rewrite this as f of u and u of x. And u of x is the term that's in the parentheses. So I do that. I need to write down u of x. So that's 4x to the 4th minus 3x cubed minus 20x. Here we have 7 divided by u cubed. So that's just a simple fraction. And we always rewrite that with a negative exponent. So this becomes 7 times u to the minus 3rd power. So then we take the derivative here with respect to u. So you get negative 21, negative 3 times 7, u to the minus 4. So you reduce the exponent by 1. And here we just use polynomial differentiation. So 4 times 4 is 16, so we get 16x cubed. 3 times 3 is 9, minus 9x squared. The root of x is 1, so that's what we get. So chain rule says f prime of x equals f prime of u times u prime of x. So we'll get negative 21u to the minus 4 times 16x cubed minus 9 9x squared minus 20, close parenthesis. I'm going to move this to the denominator before I substitute it back in. So that becomes u to the positive in the denominator. Now I can go ahead and substitute in u. So I go back over here to find u. And I raise the whole thing to the 4th power. So that's the answer. You don't need to multiply these out. It's just fine to keep it as a factored out 21. Okay, number 6 is the quotient rule, and it says final simplified answer should be have x cubed in the denominator. So I've purposely called it h of x so that you can call the numerator f of x and the denominator g of x. So f of x equals the sine of negative 5x. G of x equals x squared. So f prime of x, now here you have to use the chain rule, so it's not the cosine of negative 5x, it's negative 5, because the derivative of negative 5x is negative 5, so you get negative 5 cosine of negative 5x. So the argument never changes. If you did that anytime, you got taken off some points, just because you should never do that. The only way that you can change the argument of a trig function is use the trig identity, but not through differentiation. Okay, g prime of x equals 2x. So this is, the quotient rule, which I can never remember, so I'm going to write it out here. So you get g of x times f prime of x minus f of x times g prime of x divided by g of x quantity squared. So if we plug in what we have, h prime of x, g of x is 2x, f of x is the sine of negative 5x, then we have f of x, which is, wait a second, just did that wrong, did I? Yeah, I did the wrong way. Okay, let's try it again. G of x, x squared, times f prime of x, which is negative 5 cosine of negative 5x, minus f of x, which is the sine of 5x times 2x, all divided by x to the x squared squared. So what I would do here is I'd take the negative 5, put that out front, put the polynomial next, put the trig function next. Here in the second case, I've got the negative sign, so I've got negative, my constant is 2, my polynomial is x, and then I have the sign of, and I forgot the negative here, so negative 5x, all divided by x to the 4th. And you'll notice that I have x here and I have x squared there. So I can divide the numerator and the denominator by x, and that'll get you to the final answer, which involves x cubed in the denominator. So I just said that and then I didn't do it. Okay, so this x squared becomes x becomes 1, and the denominator becomes x cubed. Okay, so that's number 6. Number 7, it says simplify f of x before taking the derivative. Do not use the quotient rule. Okay, so some people use the product rule, but you didn't really need to use the product rule either. The whole idea here is that you can rewrite this thing. So let me write the whole thing out so you can see. So what you're trying to do here is, if you can divide each one of these terms by x squared, I can end up with 3 individual terms that are easier to take the derivative of than using the quotient rule. So x squared cosine of x divided by x squared is cosine of x. X to the 4th divided by x squared is x squared. And 2 divided by x squared is 2 divided by x squared. Now before I take the derivative, I'm going to do one last thing, which is I'm going to rewrite this as 2 times x to the minus 2 power. Okay, so that's the rewrite the original expression. So then I'm going to take the derivative. The derivative of the cosine is negative the sine. The derivative of x squared is 2x. And here you'll get negative 4x to the minus 3 power. So negative 2 times 2 is negative 4. Reduce the exponent by 1. So then finally we need to get rid of any negative exponents. So we get negative 4 over x cubed. So that's the answer. Okay, number 8. So we have f of x equals 3x to the 6 plus 3x cubed plus 14x squared minus 21x minus 21.222. You're like, why did you put 21.22 in there? Well, just to make a point that if you have a constant, you take the derivative, it's just going to disappear because it goes to 0, no matter what that number is. Okay, now we can use the power rule. Most everybody got this right. 6 times 3 is 8, so you get 18x to the 5th. 3 times 3 is 9, so you get 9x squared. 2 times 14 is 28, 28x. The derivative of x is 1. Derivative of that is 0. And then all you had to do is evaluate it at 2, and if you do that correctly, you get 647. Okay, number 9. So f of x equals 32 divided by x plus 2 squared. We want to evaluate the slope of the tangent line at x equals 2, y equals 2. And you can see if I stick 2 in there, I'll get 2 plus 2, which is 4. 4 squared is 16. 32 divided by 16 is 2. So you didn't need to evaluate the function there because I'd already done it for you. So again, this is one of those cases where you rewrite the original expression before you try to take the derivative. So we take this exponent, the term in the denominator raised to the 2nd power, and we move it to the numerator. So then, again, you could use the quotient rule, but a lot more steps and you're more likely to make a mistake. So here I have the chain rule. So I'll have 32 times the exponent, and then I will take the argument and reduce the exponent by 1, so it becomes negative 3. And the chain rule says then I multiply by the derivative of the argument inside the parentheses. So the derivative of x is 1, the derivative of 2 is 0, so I just get 1 for the chain rule part, and then I would rewrite it. So I've got 32 times negative 2, which is negative 64. Move x plus 2 to the denominator, so it becomes positive. So that's the derivative. And then you evaluate the derivative at 2, so you'll get negative 64 divided by 2 plus 2 cubed. So that's negative 64 divided by 4 cubed, which is negative 1, because 4 cubed is 64. So you get, that's your slope. So m is equal to negative 1. Then you use the point slope form of the linear equation. In this case, x1 is 2, y1 is 2. So you get y minus 2 is equal to negative 1 times x minus 2. Multiply out the right-hand side, so you get negative x plus 2. Add 2 to both sides, you get y equals negative x plus 4. So that's the equation. By the way, all of the other problems so far, if I didn't mention them, they were worth 20 points, except for number 8, and that was only worth 10 points. Okay, number 10 is just a product rule slash chain rule problem. So I give h of x is 3x cubed times the sine of negative 5x. So 3 is going to come out. And then I'm going to have the product of x cubed and the sine of negative 5x. So the derivative of x cubed is going to be 3x squared. So you take the derivative of the first times the second plus the, so I'm taking the derivative of this part because I got the 3 out front. Okay, so then you take the first term times the derivative of the second. Well, the derivative of the sine is the cosine, but you get this negative 5 because of the chain rule, so you get negative 5 cosine of negative 5x. Make sure I have enough parentheses here. And that's it. So I just need to clean it up. So 3 times 3 is 9, so you get 9x squared sine of negative 5x. Here we have 3 times negative 5, so that's negative 15 x cubed cosine negative 5x. So again, constant polynomial trig function. The argument of the trig function doesn't change, but if you take the derivative, you got to make sure that you use the chain rule to multiply this by the constant that is inside. So that's your answer. That was worth 20 points. And the last one. Okay, so this was worth 30 points. H of x equals the square root of x cubed minus 3x times x cubed plus 4. So I'm going to call the first part f of x. So that's the square root of x cubed minus 3x, and I'll call the second part of the product g of x, which is x cubed plus 4. Well, g prime of x, pretty much everybody got that. It's 3x squared. Now here you've got to use the chain rule, so what I'm going to do is go over here and do this separately. So you'll have first is you change the square root to a fractional exponent, and then you would write out f of u is u to the 1/2 power. U of x is equal to x cubed minus 3x. So f prime of x, f prime of u is going to be 1/2 u to the minus 1/2 power, and u prime of x is going to be equal to 3x squared minus 3. So the chain rule says that f prime of x is equal to f prime of u times u prime of x. So we get 1/2 u to the minus 1/2 power times 3x squared minus 3. And then we can plug u back in. So we get f prime of x is equal to 1/2. Well, before we do that, though, let's move u to the denominator. So you'll get 1/2 times u to the positive 1/2 power, but that's the square root of u. And then we can finally plug in u, so you'll get the numerator stays the same, 2 still stays the same, and then you plug back u in, which is x cubed minus 3x. So that's f prime of x. So we can go back to our first page here and say f prime of x is 3x squared minus 3 divided by 2 times the square root of x cubed minus 3x. Okay, so then you can use the product rule, which says, in this case, the derivative of the original function is going to be f of x times g prime of x plus f prime of x times g of x. So here we have the second part derivative times the first, derivative of the first times the second. And we've got everything here, so we plug those in. So f of x is equal to the square root of x cubed minus 3x. That's multiplied by g prime of x, which is 3x squared. And then we take f prime of x, which is 3x squared minus 3 over 2 times the square root of x cubed minus 3x. And that's all multiplied by g of x, which is x cubed plus 4. And what I said was simplify by having common denominator and simplified numerator in the answer. So the common denominator is going to be this, 2 times the square root of 3 square root of x cubed minus 3x. So what we'll do is we'll take the first part and we'll multiply by 2 times the square root of x cubed minus 3x, and we'll divide by 2 times the square root of x cubed minus 3x. And the second part just stays the same. X squared minus 3x squared minus 3 times x cubed plus 4, all divided by 2 times the square root of x cubed minus 3x. Now, in the first case, we have this and we have that, which is the same quantity. So when you multiply those together, you'll get just x cubed minus 3x. So we're going to have 3 times 2, that's 6. We have x squared times x cubed minus 3x. So that's this numerator. This times that's that. There's x squared, 3 times 2. And then the second part, you've got 3x squared minus 3 times x cubed plus 4, all divided by 2 times the square root of x cubed minus 3x. So that's the common denominator part. And then the numerator, we just need to multiply everything out and combine like terms. So here we're going to have 6x squared times x cubed, so that'll be 6x to the 5th. 6x squared times negative 3x is negative 18x cubed. Then we use FOIL, so we're going to have 3x squared times x cubed, so that's plus 1 plus x to the 5th. Outer is 3x squared times 4, so that's plus 12x squared. So that times that. We'll have minus 3x cubed from the inner, negative 3x cubed, and then we'll have negative 3 times 4, which is negative 12, all divided by 2 times the square root of x cubed minus 3x. And now we'll combine like terms. So I'll have 6 plus 1, which is 7, so we get 7x to the 5th. We have negative 18 minus 3, so that's negative 21x cubed. We've got 12x squared minus 12, all divided by 2 times the square root of x cubed minus 3x. So that's your final answer. It's 10 points, 30 points total, 10 points to do the simplification. and 20 points to do the product rule / chain rule. So that is it. Just a few last comments. So I have 4 online students, and they're using exactly the same material as you guys are as far as the recorded lectures and the solutions. And of the 4, well, one hasn't taken it yet because they're a truck driver who's taking it as they drive the truck around the country, and he's not been back in town to take the test. I haven't graded one of the other ones, but the 2 that I have graded, they got a 98 and a 99 on it. So obviously the test was reasonable. My other class average was 9 points higher. So that's just to show you that you can learn this stuff, and we need to figure out how to get you guys to work a little harder. So hopefully on the next test you'll do better. This is the test that historically has the lowest average. So there's some consolation in that particular fact. But again, if you have some questions that you need answering, just send me an email and I can put a video together and explain it, hopefully. Figure out if you have any questions. But I think it's just a matter of paying attention in class, asking questions in class. If you don't get an answer in class, just send me an email and I'll put something together that you guys can watch online. Okay, so hopefully next time we'll see a big improvement.